So basic manipulations. A few examples of basic manipulations: keeping or dropping variables, renaming variables, replacing or recoding variables, generating new variables from existing variables, generating random variables which are drawn from different distributions, labeling variables. So let's work again with the preloaded automobile data. Let's type that in again, just like we did yesterday, the sysuse auto.dta, comma clear. And let's start right away with something that we did yesterday. Let's tabulate rep 78. And now do tab rep 78, comma missing. So we already knew from yesterday that rep 78 in this data set is missing 5 observations, and we figure that out by looking at the number of observations that were there relative to the number of observations in the data set as a whole. 69 versus 74. We also looked at the data editor and we saw that there were missings, and we called up the observations that were missing using, for example, rep 78 equals dot or mi parentheses rep 78. But here we can just say, look, we don't want only the rep 78 values. We also want the missings as well. And so we can see that those are included if we put that missing command in there. So then we might want to say, okay, we have some things that we want to do with this, given that we know that we have these missings. So let's preserve. This is the first thing that you might do before you make some changes, if you are concerned that the changes that you are about to make may change your data to the point where it's no longer usable. So type preserve. And now remember, yesterday we said if we keep anything that is, for example, rep 78 greater than 2, we are going to have some issues. Potentially, maybe this is not going to keep everything that we want, or maybe it's going to keep more than we want. Well, let's see what happens then if you don't remember. Keep if rep 78 is greater than 2. So now, do we only have variables where the observation for rep 78 is 3, 4, or 5? No. We have missing still. So we kept more than we wanted. So this is not damage beyond repair, right? We just haven't restricted it enough. If we did want to only have 3, 4, or 5, we would have wanted to also drop those missings. Now let's go restore. You can also restore, comma, space, preserve. If you just typed restore and you hit enter, then after doing that, type in preserve again. You do not need to have the 2 lines, restore and then another one at preserve. You can just restore, comma, preserve. Now, what has restore done? Well, it's restored the data to what they were before we changed them, or essentially what they were when we preserved them last. So if you do tab rep 78 comma missing again, you can see, yeah, we have the full 74 observations, including the 5 that are missing. So if you know that you are going to be making a change that might make your data unusable for your purpose, if it restricts them too much, for example, then you might want to try preserving before you make that change. What if we did, for example, drop if rep 78 is greater than 2. And say that we don't want to drop the missings. We only want to drop if rep 78 is 3, 4, or 5. But say we do this. What happens? Well, we see, shoot, we drop those missings as well, because that greater than sign, when you're doing conditionals with that, it considers any missing to be a positive number, and generally like a large positive number. So that's not what we wanted. So now our data are too restricted. We wanted to keep those missings. So let's restore, preserve. And then you can see we've got everything back again. Let's try keep if rep 78 is greater than 2 and rep 78 is less than or equal to 5. So what does that do for us? Well, it gives us only observations that that had rep 78 values of 3, 4, or 5. Let's restore and preserve again. Maybe you think this last command was a bit cumbersome. It looks a bit long. Is there a more parsimonious way of doing this sort of thing? The answer is yes. You can say keep if in range rep 78 3, 5. You can have spaces or not. I think it's, less cluttered looking if you have the spaces, so I use them. And now let's look at what we have. We have the exact same set of observations, the exact same sample that we had after we did this command. So these are equivalent. Let's restore and preserve again. Any questions on that? Okay. Then moving on. Let's now go to generating new variables. So you can do generate with just the letter G, or you can type out any of the rest of the word after G as well. I tend to use gen, because then it's clear what we're doing, but I don't have to type generate the whole time. And let's say price 1. Let's say price 1 equals, notice this is just a single equal sign, not the double. Gen price 1 equals price if foreign equals 0. Notice that's a double equal sign for the conditional. And now let's sum price, and let's do star because we already had price, remember. Now we have price and price 1. Let's widen this so that we can see the whole thing all on one line. So we've got price and price 1. And we see that price includes the full set of observations, the whole sample, whereas price 1 is this subset, or it's comprised of this subset of the sample. It's price if foreign is 0, which is to say this is the price of domestic cars, or this is the summary of the price of domestic cars when we look at it this way. Now let's gen price 2. And let's say price 2 is price if foreign equals 1, which is to say it's just prices for foreign cars. Oops. Not minus, equals. Alright, so now let's sum all the prices again. Remember price star, and that'll include all of those. And we do something like this, we can then say, oh, I know now that that not only is my price, the average price in my whole sample is about 61, 65, but I know that on average foreign cars are pricier than domestic cars. And that is the case even though the max price of domestic cars is higher than the max price of foreign cars. So obviously then we would think that the standard deviation for foreign car prices, is smaller than it is for domestic car prices. What's another way that we could have looked at this if we just wanted to look at it, didn't want the actual variables, price 1 and price 2? We did this yesterday. We could do something like by sort foreign sum price. That was yesterday, right? And then we get for domestic and for foreign, we get these summaries. Why don't we try listing foreign and each of the price variables? Can I type? So this is a new way of seeing things. We've created 2 new variables here. We see price 2, thus far at least, it looks like it's all missing. Why is that the case? Why does it look like price 2 is missing? We created it. Well, sorry, go ahead.
52 missing observations for it, because when we created the variable, like, it's missing for all the columns here for it.
Exactly. And what should be true of price 1 when we have foreign cars?
It should have missing something.
Exactly. So we're still on domestics. But there we switch over and we see exactly this, the switch over. So keep in mind then that when you create new variables, their structure may not be as you thought was true of everything in the data set. You have missings appropriately for each of these variables, but you may not have realized that that's what was going to happen. Now let's say we don't want to have all of these variables here, right? We already had 12 variables. We created 2 new ones. We've got 14 variables. And say we decide, you know what, I don't need most of these. What I do want is the make, so keep make. I also want each of the price variables, the old price variable plus price 1 and price 2 that we just created. Let's keep foreign, say we need that, weight, MPG, and rep 78. You can now see that we have only 8 variables remaining, the 8 that we just said to keep. Stata has dropped all the other variables. Now, remember we did restore and preserve a little while ago before we created price 1 and price 2. If we decided, oh shoot, we actually wanted to keep, let's say, headspace, that was one of the variables that was dropped, and we didn't include it here, we could restore our data to that old point and then rerun the generation of price 1 and price 2 and keep everything. But maybe before you restrict your data, be thoughtful about what it is that you're dropping and what you're keeping. Make sure as much as possible that you don't have to go back and redo things because you accidentally dropped data that you wanted to keep. All right, let's describe price 1 now. We can see that it's a float. We see its display format. It doesn't have any value label or variable label. You can see over here, there's no label, variable label. So, what can we do about this? Well, we can give it a label. You can LA or LAB or the full label, which I usually do. Label var, which variable? Price 1. What do you want to label it? Price for domestic cars. Now, if you describe price 1, there is a variable label, price for domestic cars, and you can see here it exists. Now let's say that we don't like the name Rep 78. We're using Rep 78, but we know that it's really the repair record in 1978, and Rep maybe distracts us, makes us think of something else. So let's say we want to rename it. Rename Rep 78, so rename, and you can just do REN, but I tend to use rename, the fullness of it. The variable that you want to rename, and the name that you want it to have now. And we can see over here, Rep 78 no longer exists. We now have Repair 78. Say we think now like, oh, you know what, I actually want Rep 78, but I also want Repair 78. Maybe I'm going to do something different with them. Then you can generate Rep 78 equals Repair 78. So now these are the exact same thing, but they have different names. You've got two versions of the same variable. Now let's say we don't like that Repair 78 has missings coded as a period. Let's say that instead of being a period, we want to change those missing values to 99. Well, then you can replace Repair 78 equals 99. But then you say if. It's important here, if missing Repair 78. Or you could also say if Repair 78 equals dot. The reason that we have to include that is that if we don't, then every single value of Repair 78 would change to 99. And we don't want that. We only want the missings to have that. Now if we tab Repair 78, we see that we don't have to now include the comma missing in order to see everything. We've got those missings recorded as 99. But be careful if you, it would be silly to summarize Repair 78 anyway, since this is a categorical variable. But if you did summarize it and for some reason thought it was meaningful, it would be very different if you had the missings coded as period or as 99. Let's do that once more. So in Repair 78, the missings are coded as 99. In Rep 78, the missings are coded as 69. And if, again, we did think that somehow the mean of these values was of interest, we would be wrong. But if we did, well, it would look very, very different. So you do have to be careful when you have data that comes coded as 99 or 9999999 when it's missing, as I mentioned yesterday. Let's say we also now want to change Rep 78 so that the missings are 99, but we don't want to use this replace variable. Well, we can also recode. So let's recode Rep 78. And then you can put in parentheses the value that you want to change. So it doesn't have to be missing. You could change the 1s to 2s, in which case you would put 1 equals 2. You could change anything to anything, but we're going to change the missing, the dot, to 99. And now, if we do a crosstab, we can see that both Repair 78 and Rep 78 are the exact same. You could also use this command, which I'll show you a few more times, which is worth using a number of times to make sure your variables are as you think they are. Here we can do assert Rep 78 equals Repair 78. And because every observation of rep 78 is the exact same as every observation of repair 78, nothing comes up here. In this case, it's like when you go to the doctor for some tests. No news is good news. So there's no news here, so everything's good. If we instead asserted that they were not equal, we get this warning. No, there's 74 contradictions in 74 observations. You just asserted something that's not true. The assertion is false. If we asserted that equals equals and it wasn't true, we would also be given a message of this sort. Okay, let's generate a new variable. Let's call it ratio 1. And let's make it miles per gallon divided by weight. So we've created this new variable. We know it's over here. We know, we just created it. There's no variable label. Let's create it. So you can just copy my code. See, though, if you can remember how we did it without just copying what I'm doing. And see if it makes sense to you that label is what we gave it, miles per gallon per pound. If that doesn't make sense to you, that's going to be something to think about with your math skills and maybe your economics skills. But you should be able to puzzle out that if we divide miles per gallon by the weight of a car, then we're finding out the miles per gallon per pound of the car. All right, let's summarize the price and get details, and then let's return list. Remember we did this yesterday. You get a list of scalars that are just temporarily there. And just like yesterday, let's create the local average price from our mean. And now it looks like Stata did not properly code things, but let's generate cheap variable. Sorry, not Stata, LaTeX did not properly do things. We want to say if price is less than this local average price, we're going to generate this variable called cheap. Now, what do you think that's doing? So these should have the back tick on the left side and the single quote on the right side. So what do you think that that this has done now, what we just created? Well, it's created a set of observations for price for any car that is priced below the average. So let's find out how many observations had prices below the average. So let's count if price is less than, and then call the local average price. If, not in. 52. So 52 cars in our sample out of 74 had prices that were below the average price. Now, if you think back to how we ended the day yesterday, remember, we did not have price as a normally distributed variable. Price was concentrated at the low end of that distribution. We had a long tail. So it makes sense that we would have a lot of observations that have prices below the average when we call the average the mean. So now let's look at those. Let's tab cheap. So cheap is what? Yeah. So it's a dummy. You may sometimes see the generation of cheap, when we did that, contained within that sort of thing, contained within parentheses. Let's create a new one called foreign cheap, or for cheap. And now let's multiply this by foreign. Foreign, remember, is also a dummy variable. Tab foreign cheap. We now see that we have only 13 cars that are cheap in this sample, and this is out of all the 74 cars. 13 are both foreign and have an average price below the average price in the sample. So remember, if we do tab foreign, we can't do that now. We can't just do tab 4 because we have foreign and for underscore cheap. So we have to do at least FORE or IGN, however you like. If we do that, we get this. And let's say, you know what? We want to have separate variables for each, like separate dummies for each foreign and domestic. Well, let's tab foreign then, comma, and then we can generate foreign dummy. Now that might not be the best name for it, but let's just use it for now. And look over here now at the variables that you have. You now have, as a result of typing this, you have two new variables, foreign dummy 1 and foreign dummy 2. And Stata has been thoughtful enough to include variable labels for you associated with the original variable foreign. So foreign dummy 1, it's a dummy that is 1 if foreign was domestic and 0 if foreign was foreign. Foreign dummy 2 is going to be a dummy variable that is 1 if foreign was foreign and 0 if foreign, the variable foreign, was domestic. So let's tab foreign dummy 1. And we can see 52 observations are 1, 22 are 0, the same as when we had, if we just tab foreign, here 52 observations that were domestic and 22 that were foreign. Now note that I just typed tab foreign after typing tab foreign dummy, yet Stata was smart enough to know that I wanted the exact variable foreign. It was not confused, even though we have foreign, foreign dummy 1, and foreign dummy 2. So if you have some commonly named variables, Stata will get confused unless you call the exact variable name. But if you do call that, it's smart enough to figure it out.